Hello, it's James from XRobots.co.uk. This is part 2 of building a virtual reality hoverbike simulator. I'm sponsoring and building the hardware, and then students at Portsmouth University are going to write the software and do all the 3D modelling and all of the game design. And hopefully at the end we'll be able to publish everything, including plans to build your own. So far I've built this bike that you lean to steer the game. You can lean sideways and backwards and forwards, so check out part 1 for more information on that. Today I really need to get some stirrups on with the foot switches, fix the seat on and sort out all of the electronics so the switches and all of that stuff works and it's tracked into virtual reality. One of the first things I need to do is attach something to put my feet in, and I don't want to get my feet on my trouser legs caught in the mechanism there. So basically we need a side panel that I can rest my leg on and put the switch and stirrup on. So I'm going to add a panel like this, which is spaced out so it comes over the edge here. Attached to the piece that moves, of course, and that'll fit just under the seat at the front, and we'll stick one on each side, and then we can put a peg on and a foot switch. So I've painted that panel black and attached it. It's just spaced out with some battens of wood screwed on from the inside, but now I need to attach the foot switch. I found these metal industrial foot switches on eBay and they're meant for machines, so you press that with your toe, but I'm going to flick it around the other way so you can rest your heel on there and press with the toe there, and I'm using these brackets to attach them, which conveniently happen to have the screw holes in exactly the right place. So I can screw that on there and screw that onto there and mount it wherever I like. It's also got this other convenient hole here where we can put a big bolt or a bit of studding through. Obviously it's bolted through the wood as well, and so there we can make a heel hook to put the heel of your shoe on so your foot doesn't slip off and your toe can press the pedal. Right, it doesn't feel too bad. Even without the heel hooks I can keep my feet on there quite comfortably actually. Now I can use my legs to help tilt me side to side and help it to pose me backwards and forwards, so pretty happy with that. It's a shame they're not red, but I might print covers for the brackets. Probably not going to paint those. We could put rubber pads on them to make it easier to grip, but I think it'll be fine if I had rubber-soled shoes on. Here it is. I've made a cover for each side, so we've just got a red feature there instead of the grey bracket. On the handlebars I've added a couple of buttons there. Those are going to be wired together, and those will be wired to the trackpad feature on the top of the Vive handset, but I need to do something about these brake levers. Obviously these would normally have cables attached which would pull your brakes, so we can use that to actuate a switch. So I'm going to fit a couple of micro switches in the middle there on a mount and basically just tie that on to the lever, so when you pull the lever it switches the two switches. So I've made a clamp with the collar that goes around the shaft there, and now my plate is mounted on the front. And now you can hopefully see the switches getting switched. They're basically cable tied on with 2 bits of string. It's a bit hacky, but I can't pull the switches too far because the levers don't go any further, so that'll work fine for now. I've made a nice cover for those switches, but before I put that on we need to actually wire them up. So the whole thing is going to be tracked into virtual reality using the Vive Tracker, which we can use a bit like a handset to track another object in space in all 6 dimensions. On the bottom of that we've handily got some connectors we can wire switches to, and we can emulate the buttons on a handset so they can easily be read into your Unity or Unreal Engine environment. Inside here are some gold contacts which are slightly sprung, and these are pogo pins. Now I looked on Thingiverse to see if someone had already produced a coupling for this, and they have, and I managed to download and print this thing. And they also had a link to DigiKey where there's some gold pins you can use. So I've made that and I've soldered wires to them all. Unfortunately they're not a standard 0.1 inch spacing, so they don't fit on strip board, and that should couple on there. So we need to make a base to attach this so that this can be screwed down, and it should make a good contact and we can wire our switches to the other end. So this is the Vive Tracker datasheet, which is freely available online, but we can see the pinouts here for the pogo pin. So we've got a ground pin, which is common. We've got an output, which is attached to the pager motor that you get in the handset for feedback. And then we've got 4 button inputs. So we've got the grips, the trigger, the trackpad, and the application menu button, which is that one. Quite importantly, that's different from the system menu, which we've got not really any control over, but that one can be programmed into the game. So basically on my handlebars, I'm going to implement that one and that one for the 2 buttons, and they'll be the same on each handlebar. It's likely the person is riding one-handed anyway, holding an actual Vive Tracker in the other hand. And then the pedals I'm going to attach to the grip and the menu button, and I'll have to repurpose that menu button for the application so that it actually operates the foot pedals. So I've printed a plate with the 6mm photography mount screw, a hole there, and it's also got a lump that keys into this, which is a bit like a standard camera connector. So we should be able to pop that in there and screw this on here. So that should all be good, and we should have a good contact with those pins on the bottom of the Vive Tracker. So that Vive Tracker mount mounts to this thing, and the wires come out the bottom there, go through a hole, and they poke out here. So this piece also acts as a cover for these bolt heads, so that fits right on there, and it will screw on, and that leaves the wires here ready to wire into our switches on the handlebars. It also leaves the Vive Tracker there so it can be seen by the lighthouses and track the whole motion of the bike as it moves. So that's all our controls. So we've got inputs into the game, and we can steer to lean the bike around, and that's tracked by the Vive Tracker. But what about when the player crashes into something or they go really fast? We need some feedback so the player feels like they're really there. So we've got two 12-volt fans for car dashboards, one on each side. So obviously we can blow air towards the person when they're going forwards, or when they bank and turn left or right, we can blow either fan. So those are going to be speed controlled and controlled by a custom interface from the game. And obviously the person will have headphones on as well for the sound, so they won't actually hear the sound of the fan. Inside the bike itself, we're going to fit a rumble motor, which is made out of a windscreen wiper motor with the worm gear cut off, and that's going to be screwed inside. We'll put an off-center weight on it, and again that will be speed controlled and controlled from a custom interface. So here's my interface box. I've got an Arduino Uno in it with USB, which will attach to the computer running the game, and 3 motor drivers. We've got 12 volts in on this side, which will go to a power supply or a battery, and 3 lots of 12 volt out to go to those 3 motors, the rumble motor and the 2 fans. And the way it'll work is you can send a serial string to the Arduino, which will set the speed of those motors. So the fans, for instance, will be tracked throughout the game to make them run at the speed you're traveling through space. And the rumble motor, you'll be able to set it as you wish and turn it on and off as you wish and run the motor faster or slower. Now I've left this whole thing pretty hacky. I'm using jumper pins here, and there's a piece of breadboard in here with all the pins on, and that's so it can be reconfigured during the game development without too much trouble. Right, my code's pretty basic for this. It's basically doing a serial read, checking if there's serial data, if there is, looking for an identifier A, B or C, and basically then reading in the next value as a string and sending that out to the various analog pins for the 3 motor speeds. So I haven't got the rumble motor connected yet, but I have got the 2 fans connected there, as you can see. So if I were to send B and the number 255, that will start up the fan. It also echoes back the value there. I can make that go slower, so let's say 100, and the fan slows down. If I want to set off the second fan as well, then I can start that one up, or I can make that one go faster, so as you go around corners the air blows from one direction more than the other, or we can simply make them both go full pelt when we're going at full speed in the game. And obviously the fan layout can be decided upon by the students, and any other thing, and of course we can hack this box and hack the code to make it behave in a different way if we wish. So that motor is now attached to its bracket. It's wired in. I've just run the wire out the front, but it's on a pretty long extension lead, so it could be moved around to any exit point. So this is fitted just in front of the seat there. You can see the handlebars, and if I give it some data there on one of those channels, we can see it turns around. That's 50 out of 255. This is 150, and you can feel that vibrating through the bike, and this is 255. But obviously that would be only run when you crash into something in the game or you scrape alongside something, and that speed is fully adjustable through all of those values from 0 to 255. I've installed a nice panel on there, which means you can't fall in or get your hand stuck in that rumble motor, so now the main build is pretty much finished. But of course it's totally hackable. The project for students is going to last around 6 months or so we can always add bits and pieces to it, or change the switches if they don't like them, or add some other gameplay aspect. But for now, it's time to take the HoverBike simulator down to Portsmouth University. Right, I'm down at Portsmouth University, and we've temporarily put the HoverBike simulator in Ted's office. And I'm here with the team who are going to write the software for it, which is Adam, Ashley, Matt and Rebecca, and we'll be looking at those guys more in the future when they've actually done some work. Alright, so we'll be revisiting Portsmouth University with that VR bike in the VR lab, which has got the HTC Vive set up and everything, and hopefully next time we'll have some rudimentary gameplay with a kind of thing fleshed out with blocks, with the controls working and all that stuff, and we can talk to the team about how they've done it and the concepts for some of the art and all of those things, so don't forget to subscribe for more updates on this project and all the other projects. Also, it's really important to say that all my projects are funded through Patreon, so have a look at patreon.com/XRobots and you can get access to some exclusive rewards, including a live broadcast with me, all my videos early, and almost daily sneak peeks and pictures. Alright, that's all for now.